I've had some great comments in my last few videos, so thank you for the people who've been leaving comments and questions and constructive questions. One of which was someone mentioned they'd be interested to see the coil hooked up to the oscilloscope and see some readings. Also, my friend Dave also asked me, he said, well, what's the resonance frequency of your coil? And so that got me thinking that really I should be sharing some information as to how to test the resonance frequency of your coil. Now what I'm going to show is applicable for any type of coil and also for transformers. So there are things to lower your frequency or increase your frequency. People talk about LC tank, which is inductance capacitance. So that means if your frequency is too high, you can lower your frequency by adding a capacitor. Depending on what type of power you're using. If you're using DC power, you'll have to put your capacitor in parallel, because if you put your capacitor in series, it will actually block your DC current going through. But if you're using AC, it's a different beast. AC, you can have your capacitor in series and parallel. Just a quick disclaimer before I carry on. I'm not responsible if you get hurt or injured or if you misunderstood what I'm trying to say. Please do your experiments at your own risk. I'm really sharing those videos to share my knowledge and my experiments with you. Saying that now, we'll carry on with testing the resonance frequency of the coil. So you'll need a function generator, an oscilloscope. So what you need to do is you need to connect your positive and negative to your coil. I do have a center tap here on this coil. So you can connect your oscilloscope probe to one of the wires. It doesn't really matter, because here what we're trying to see is what is the maximum voltage we can get out of the coil, and the maximum voltage will then indicate what is the maximum resonance frequency. For that, we need a function generator set to 5 volt. We don't need a very high voltage. We don't want to damage anything, so it's really just low voltage to see what is your output voltage. So if your input peak to peak is 5 volt, which is what I've got set here on my function gen, if your input amplitude is peak to peak is 5 volt, then you want to get as close to 5 volt as possible with your coil. So to do that, you just connect your oscilloscope to your wires of your coil. So I'll use the very first and the very last wire of the coil, like this. Okay, I've got my oscilloscope probe connected to the center tap, but if you don't have a center tap, it can be connected to anywhere. I would probably connect it to the positive if I had only just 2 wires, because it's probably just a habit, I suppose. And you can see here my ground clip of the oscilloscope probe is not connected anywhere, and that's why I put a disclaimer at the beginning of this video, because people tend to connect this ground clip to their function generator, which is usually grounded, and it damages everything. So for those kind of experiment, I've got my clip disconnected. Again, do this experiment at your own risks. Okay, so for now, what we're looking for is the highest voltage output of the coil. So for now, what I'm going to do is I'm going to start low and then go up. So here I'm going to just reset it back down to 10 kilohertz. And why 10 kilohertz? Because I know that the coil is actually resonating a lot higher than that. So just to save a bit of time here, so 10 kilohertz. And I've set an amplitude of 5 volts. So what we're looking for on the oscilloscope here is the highest voltage peak-to-peak output that we can get from the coil. And the highest voltage will indicate your true resonance frequency of your coil. Apologies for the background noise here. I've got a 3D printer and I can't stop it. Right, so I don't know if you can see the readings, but we've got a 10 kilohertz and we've got peak to peak. It jumps between 4.2 volts, 4.4 volts and 5.2 volts. It's jumping around a lot at the minute, so we're not really sure if this is the peak resonance frequency. But again, like I said, we want the peak to peak on the oscilloscope to be as close as possible to the peak to peak of the function gen. I'm just gonna jump now from 10 kilohertz and just do an increment with the knob here. Just do an increment of 10 kilohertz, and you'll see the readings here on the oscilloscope. Even though you can see from my function generator it's 10 kilohertz, but on the oscilloscope it sort of jumps ever so slightly. It's not extremely stable, but at the minute we've got 10 kilohertz, so it's pretty accurate for now. Again, we're looking for max peak voltage, okay? So I'm just gonna start the sweep. So I'm at 20 kilohertz and it's around 4.1 volt, and then it jumps. We get this little spikes, if you like, to 5 volt, but that's not good enough. So we'll do a sweep, we'll carry on. So here it seems we're going down a little bit, so that means we're going away from our resonance frequency. We'll keep going. So here we seems to be hitting a plateau. We'll keep going. This time it's taking a bit long, so I'm gonna start to jump from 100 kilohertz of increments. So here the reading here is inaccurate, so I'll have to auto set just to show you where I'm at. So here we're at 2.1 megahertz and peak to peak is 3.92 volts. So we haven't really hit resonance yet, so we'll keep going. Oh, here we go. So we're starting to hit it. This is the true resonance frequency of the coil, and the frequency is 3.69 megahertz from my function generator. So the oscilloscope is jumping a bit, but from the function generator, the resonance frequency of this Caduceus Pancake coil is 3.69 megahertz. This is how you get the resonance frequency of your coil, and I can maybe detune it, and you'll see that we are going further away from the almost 5 volt peak here, 5 volt peak to peak. So if I keep it down, you can see even the wave is actually just jumping down here. We're getting back to 3 volt. I wanted to touch base on the resonance frequency, and when we test the coil for the resonance frequency, the coil can resonate also at a octave harmonic. What it means is that you can still find resonance point in your coil at other frequencies. For example, the coil that I built is resonating at 3.96 megahertz, but it doesn't mean that it's the only resonance point. That's what I wanted to clarify a little bit. And I've got here Dave Lawrence's website, and he spent an enormous amount of work and effort trying to share his knowledge and his expertise on several topics. Reason why I'm showing Dave's website, it's because it's very relevant information regarding resonance frequencies. So for example, the resonance frequency is 3.96 megahertz, but it could be a harmonic of it. We could still use a harmonic of it to make the coil resonate and still get some of the power out that we require for our system. So for example, we could have a frequency divided by 2, or divided by 4, or divided by 8, and those will be harmonics of, it's called octave harmonics. So an octave is 8, but we can have harmonics of it. So we can have a divided by 4 or by 2, and we've also noticed that when I was tuning the resonance frequency of the coil, there were some points where it was getting pretty close to the actual resonance frequency. So those would be harmonics of the actual resonance frequency. And you can see that you can divide your resonant frequency of your coil by 2, 4, or 8, or a ratio of it. So I just wanted to make this point, and I hope this helps.